All right, guys, are there any questions over any of the assignments thus far? Any questions over any of the homework assignments thus far? Now, what we're working on today is completing the square. What we're doing today is completing the square. We didn't do one of these yesterday. We didn't solve one by completing the square all the way through yesterday. And that's what we're going to be doing today. Now, the first part is A equal to 1. If not, make it so.
How hot is it?
72. If not, make it so. Okay. Sounds good. Now the second part is to get the constant terms by themselves. And leave 2 spaces. So the second step is to get the constant term by itself and to leave 2 spaces. Now the third step is to find C, which is b over 2 squared, and plug it in. Find C, b over 2 squared, and plug it in. The last step is to factor and solve. And the last step is to factor and solve. Lots of thinking about it and solving. Some, not all.
Whenever they give you life sentences, instead you can choose to do algebra 2 the rest of your life. That's really?
No.
It's not up to I didn't do anything.
Well, the converse is, or the inverse of that is also true. So, did we get these copied down? Okay. These are going to be the main steps that we're going to use to solve these here. Now, we did that one yesterday. We're going to go on and look at this one here first. X squared plus 6x minus 9 equals 1 is the first one we're going to solve today. So, ax squared plus bx plus c is our normal quadratic equation. So a is the term in front of x squared. Here it is equal to 1. So the first step, we are good, because if a is 1, we're fine. If it's not, we need to make it so. We need to make it so that it is positive 1. Step number 2, get the constant terms by themselves and leave 2 spaces. So we want to move the 9 away from the x and x squared. And we can do that by, we can subtract 9 from both sides, which will tell us that x squared minus 6x plus blank equals negative 8 plus blank. Because again, we want to get the constant term by itself and leave 2 spaces. And the reason we're leaving two spaces is so that we can plug the C value back in, and we have a spot for it. Any questions on steps 1 or 2? So step 3 is to find the value of C. And C here is equal to B over 2 squared. And in this case, the value of B is what? It is 6, but it would be negative because we take the sign with it. So since it's minus 6x, we take the negative 6. Negative 6 is our value of B. If we divide negative 6 by 2, we get negative 3 squared, and negative 3 squared is positive 9. So we add 9 to both sides. And now we need to factor our right side, or the left side, the x squared minus 6x plus 9. Now we'll have x, and the number that goes with it will be the number, the negative 3, the number inside the parentheses before we square it. And negative 8 plus 9 is 1. Now, probably you already noticed that we ended up back with x squared minus 6x plus 9. All that's saying is that x squared minus 6x plus 9, what we had to begin with, was a perfect square trinomial. So if we'd noticed that, we could have gone on and factored it and started there. If we didn't, we could subtract the 9 like we did, find C, plug it back in, and factor it, and we still get the same spot. So if you notice that x squared minus 6x plus 9 is a perfect square trinomial, we could have factored it to a set of parentheses squared and gone from there. Yes, sir?
So I was looking at, I was asking about the positive 9, subtract 9.
Yeah. If we didn't notice that this here from the beginning was a perfect square trinomial, we could have factored it down to a set of parentheses squared and solved. These steps still work, even though it was one to begin with. Now the next step, the last step, is to factor and solve. Well, we factored it. Now we just need to solve by taking the square root of both sides. Well, here the square root and square will telling us we have x minus 3 is equal to plus or minus. What's the square root of 1? What times itself is 1? 1, because 1 times 1 is, what's the cubed root of 1? What times itself 3 times is 1? 1, because 1 times 1 is 1, times 1 is still, no matter what the root is, we can take the 27th root of 1, it's still 1. And last but not least, we need to add 3 to both sides. And if we add 3 to both sides, we get x is equal to 3 plus or minus 1. Now, whenever we get to this part here, we do need to ask ourselves, or kind of check and see, can I add these two numbers together? Can we add 3 and 1? Yeah, can we subtract 3 and 1? If we can add them, that means we can also subtract them. We need to. So we need to do 3 plus 1, which is 4. We also need to subtract them. 3 minus 1 is. So the answers for this here are 4 and 2. If after taking the square root, we still have a square root, so instead of having 1, we still had a square root in 1's place, we won't have to fully simplify like we did here. If it has I, we won't have to fully simplify, and we'll see those here in a minute. But if we're actually able to add the two numbers and subtract them, we need to do that. So like here, we needed to add 3 and 1 and subtract 3 and 1 to get our two answers. Questions on any of this here? Okay. Let's look at the next problem here. Now this one here, I can tell you, is not going to be a perfect square trinomial from the beginning. Because all the ones that have worked out to be a perfect square trinomial, well, on the last one, our third term was 9. Well, 9 is what? 3 times 3. The one we did yesterday that worked out that way was 64. Well, 64 is 8 and 8, yes? What?
That was like, that was third grade.
Okay.
It's like I 8 and I 8 so 8 times 8.
There you go. Now looking at this here, is 8 a perfect square? Can we multiply a number by itself and get 8? Well, we can. It's just 2 square root of 2 times 2 square root of 2. It's not a nice number. It is possible, but it doesn't work out nicely. So there isn't one for 8. So that means the only method we have for solving this is our completing the square. So the first step is a equal to 1. Is the number in front of x squared 1? Yes. Okay, we can move on to step 2. Get the constant term by itself. So we would subtract 8 from both sides, and we want to leave 2 spaces. So we'd have x squared minus 4x plus blank is equal to negative 8 plus blank. Now the reason we're leaving those 2 spaces is, again, when we find the value of c, we're going to plug it back in. Questions on step 1 and 2 so far? Step 3 is to find the value of c. Well, c is equal to b over 2 squared. And in our case here, the value of b is indeed negative 4. Now, we don't plug this in completely into the calculator because what we get before we square it is what's going to go inside our factor. Now, negative 4 divided by 2 is negative 2. And negative 2 squared is 4. So what we add in the 2 spots, or what we're adding to both sides, is going to be 4 and 4. Because if I add something to one side, I have to add it to the other. Now, in the earlier, or in last hour, they did ask if there's going to be any case where we don't add it to both sides. And there is one. We could have put both 4's on the same side of the equal sign, but we would add it and subtract it. Because we would put plus 4 minus 4. Well, 4 minus 4 is, so essentially we added 0 to it. But here, we're going to just do it to both sides. The only time we would put it on one side as positive negative is if we're dealing with conic sections and doing those. But we're not going to get to that in here. So we don't have to worry about that. Now the next part of this is to factor it. So we're factoring x squared minus 4x plus 4. Well, we know we'll need the x, because that's coming from factors of x squared. Yeah, minus 2, negative 2, is going to go in with it. Now the negative 8 plus 4, negative 4. So we got it c plugged in. We did part of step 4. We factored it. Now we need to solve by taking the square root of both sides. Here the square cancel, giving us x minus 2 is equal to plus or minus. Whenever we take the square root of both sides, we need the plus or minus. Since we have a negative inside of a radical, it's going to come out as I. Whenever we have a negative inside of a radical, it comes out as I. We're pulling that negative 1 out as I, which leaves us with the square root of 4, which is 2. Equal the square root of negative 1. It is by definition the square root of negative 1. Last step, what do we need to do? Add 2. We need to get x by itself. Telling us x is equal to 2 plus or minus 2i. Is 2 and 2i, are they like terms? Can we add or subtract those? Well, no, because we're saying 2 plus 2 times the square root of negative 1. Those are not like, they're not the same. So that's it. That is our final answer. Because 2i and 2 are not like terms. We can't actually add those. because 2 is considered our real number and 2i is our imaginary term. Because if one of them has I, like this here, we can't add or subtract. If what comes out of the square root is either imaginary or irrational, has a square root still with it, we're not going to be adding or subtracting. We could possibly simplify if it's being divided by something, and we can simplify it all the way. But this here is our final answer. Questions on this here? Let's look at the next one. Okay, we have x squared plus 8x minus 5. So is a 1. So we want to get, so that takes care of step 1. Step 2, get the constant term by itself and leave 2 spaces. So we wouldn't minus 8, we'd add 5. We'd add 5 to both sides, telling us that we have x squared plus 8x plus blank is equal to 5 plus blank. We leave the blank so that we can add c back in later. Questions on this so far? Now c is equal to b over 2 squared. And for this problem here, what's the value of b? 8. And it is positive. Now 8 divided by 2 is 4, and 4 squared is 16. So this time we're adding 16 to both sides. X. And the number inside the parentheses before we squared it is 4. And it's positive, so we would get x plus 4 squared equals 21. Now, because it's equal to a positive number, we know that we'll have real answers. They're might not be rational, but we will have real answers. Because we get complex or imaginary answers when we take the square root of a negative number, yes? Because our next step in solving is to square root both sides. So on the left side, these will cancel, telling me that I have x plus 4 equals plus or minus square root of 21. Yeah, no, we would get 4 point something. But for us, unless it tells us to approximate the answer, I'm going to leave it as a radical. Now, if it does tell us to approximate our answer, I'm going to wait to the very end to approximate that radical. Because what I would want to do first is to minus 4 from both sides, which is going to tell us that x is equal to negative 4 plus or minus the square root of 21. In the yellow calculator, we can do the square root of 21, hit enter, see what it tells us. And the first number it's probably going to give you back is the square root of 21, because there are no perfect squares in it as factors, so we get this here. Now, if I wanted to approximate, I would plug this in and this in. I would plug those in as a whole and tell it to approximate the decimal, or plug it into the graphing calculator and hit enter, and it'll approximate the decimal for me there. And the reason I do this is because if we did it the other way and we approximated it here, that means I have an approximation and then an approximation, so we're having to round twice, realistically, to get the answer. The more times you round, and the earlier that you round, the farther away from the actual answer you will get. So if you have to round, mathematically, you wait till the very end to round, so you get as close to the actual answer as you can get. Because this is the answer here, which doesn't seem like a big issue rounding early, because I know Gilstrap has brought a bunch of the ag questions to me, and they have, and some of them, the reason that the answers were off from what I was getting is they rounded pounds to kilograms or one of their units first, which, okay, that's not a big deal, but for one of the problems, it made a difference of a 40 pounds of dog feed off of what they actually needed because of a simple rounding at the beginning. So for some, that could be a huge amount. So if you have to round at the end. Questions on this here? Okay. Are you ready for the next one? Because we only have, I think, 2 or 3 more. 3 more. Okay. If we look at this one here, so first step is a equal to 1, so it is, so we can move on to step 2, yes? What is a? Okay. Is a equal to 1? No. If not, make it so. So what would I need to do to 3x squared to make the 3 1? We would divide it by 3, because 3 divided by 3 is, but if I do that, I have to divide everything else. Because 3x squared divided by 3, 3 divided by 3 is 1, leaving us with x squared plus x plus. Now, since we didn't divide by a negative, the signs don't change. Because we just divided by 3, so we still have positive, positive, positive. If we divided by negative, we would change the signs. Or kind of dividing by the negative is somewhat tricky. You don't like dividing by negatives? Yes, sir? You can do it in the calculator. Because you could plug in, so 3 divided by negative 3 if we had that. And it will tell you the sign. Yes, sir? Yeah. Because the first step is a equal to 1, if not, make it so. Is a now 1? Okay, we've got step 1 done. Step 2, get the constant term by itself and leave 2 spaces. So here we would which tells us we have x squared plus 4x plus blank equals negative 5 plus. Okay. Steps 1 and 2 are done. Now we look at step 3. Step 3, find c and plug it in. Well, c is what? B over 2 squared. What's the value of b? And 4 divided by 2 is 2. And 2 squared is 4. So we'll have 4 and 4. Which brings us to our last step to factor and solve. So inside the parentheses we have x plus 2, because what was inside the parentheses before we finally squared it was a positive 2. So we have plus 2 equals negative 1. Solve. Square root both sides. Which tells us that x plus 2, because these 2 cancel, equals plus or minus. What is the square root of negative 1? What is, it's I. Because by definition, I is the square root of negative 1. Because what we've been doing with it is we'd pull the negative out as I, yes? Which leaves us with what inside? Positive 1. Square root of 1 is, so we just have I. Last step, minus 2 from both sides, telling us x is equal to negative 2 plus or minus I. And that's it. Because we had I after we square rooted both sides, we know that these will not combine. We can't combine those 2 terms, so we can leave it as this here. Questions on any of this here? We ready for the next one? Okay. Almost. Negative 3. Because the first step is a equal to 1. we aren't really saying it, but we want the 1 to be positive. So negative 3 divided by, negative 3x squared divided by negative 3 is x squared. Negative 18 divided by negative 3, the negative and negative make a positive, and it would be 6x. Our negative 6 divided by negative 3 is going to be positive 2 is equal to 0. Okay, that takes care of step 1. Step 2, subtract 2 from both sides. Yes. 6x plus blank equals negative 2 plus. So c is equal to b over 2 squared. What's our b value this time? 6. So we have 6 divided by 2, which is 3, and 3 squared is 9. Okay, that takes care of steps 1 through 3. Step 4, factor and solve. So we would have a set of parentheses squared, x, and what was inside the parentheses before we squared it? Positive 3, so we'd have x plus 3 squared is equal to 7. Now we solve. We would square root both sides, telling us that x plus 3 is equal to plus or minus the square root of 7. And we could try to simplify the square root of 7. Well, it doesn't simplify because 7's prime. So the last step would be 2 minus 3 from both sides. Minus x is equal to negative 3 plus or minus the square root of 7. Questions on any of this here? We ready for the next one? I want to look at this one here, because this one here is the first one we actually have it equal to something, yes? Now, we'll get back to the first step here in a second, but the second step was what? Get the constant term by itself, yes? Is the constant term already by itself? Yeah, we can leave it as this here. We don't have to move it over. We don't have to add 68 to both sides to get it equal to 0. Because we could then make a equal to 1. Then the next step is to subtract that number back over. We can leave it where it's at. We don't have to move it over, especially if we're doing completing the square. The only time we want this here to be 0 is if we're graphing or factoring. If we're doing completing the square, we can leave it there. If we're graphing, factoring, or our last method, the quadratic formula, we want it equal to 0. If we're using one of those 3 methods, we want it equal to 0. Completing the square, we can leave it there. So yes, we can start off by dividing everything by 4. Which shows we have x squared plus 8x plus blank is equal to negative 17 plus blank. Because when we get the constant term by itself, we want x squared and x on one side, all the x squared and x's on one side, and all the numbers without x on the other. B over 2 squared. And in our case here, b is, now 8 divided by 2 is, and 4 squared is, so we're adding 16 to both sides. Now we need to factor. X squared plus 8x plus 16, you get x plus 4 squared. And last but not least, we would square root both sides. X plus 4 squared, the square root of it is just going to be x plus 4 is equal to plus or minus I. Because square root of -1 by definition is I. Any other questions on these here? We ready for the next one? I want y'all to watch this one, so don't check out on this one here. You don't have to follow along writing it down, but I want you to see this. Because completing the square works nice in most every case. And for this one here, we would do the same method. The method's not going to change. Because here is a equal to 1. Well, no. So we need to make it so, which means I'm going to divide everything by 2. 2x squared divided by 2 is? We need a equal to 1. And the reason for it comes into when we factor. Because the reason we been putting x by itself, we just have x, is because the first term is just x squared.
So what we divide 5
Yep. So we're going to leave it as a fraction. Plus, if we can simplify those at all, we would. So if it had been, say, 10/4, we could bring it down to 5/2. We can simplify them and bring them down as low as we can. I wouldn't turn them into a decimal. Because again, at the very end, we're going to have to square root both sides. It's going to be easier to work with square roots and fractions than it is a square root and a decimal. Now, it still brings us to the same step 2. We get the constant term by itself. So we would subtract 67/2 from both sides. Notice we have x squared minus 5/2 x plus blank equals negative 67/2 plus blank. So this is still the same steps we've done so far. We have fractions now. We have numbers that don't look as nice, but the process hasn't changed. B over 2 squared. And here our B value is negative 5/2. Now again, the calculator can do negative 5/2. Because we could type that into the yellow calculator, negative 5/2 divided by 2, and it'll tell us it's negative 5/4 squared. And we could square this in the calculator. Now we know the number is going to come out positive because a negative times a negative is a positive. 5 squared is 25. 4 squared is 20. And we're going to add it to both sides. Now before, what we were doing with factoring, trying to factor x squared minus 5/2 x plus 25 over 16 would be a little challenging to try to figure the factors of 25/16 out. But we know whatever is inside the parentheses before we square it is what goes in there. Yeah, x minus 5/2 squared. We just have that. Equals, well, negative 67/2 plus 25/16. Those are two fractions. Yes, two numbers. Plug it in a calculator. Let it do it for you. Because we'll have 16. I think it's negative 511. Again, I didn't do that in my head. Because last hour was Algebra 2, yes. Because I did that not 40 minutes ago. So, yeah. Now we solve, because we factored it and solved. So we would square root both sides. Here we'd have x minus 5/2 equals plus or minus. Well, the fraction is negative, so I would come out. That negative would come out as I. We would split this apart, and we could plug the square root of 511 into the calculator. It's going to give us back square root of 511, or a decimal, one of the two, because there's not a perfect square factor for 511. But the denominator 16, square root of 16 is, and bless you, The number before we squared it was negative 5/4, not negative 5/2, correct? Yeah. But last but not least, we need to add 5/4 to both sides, which will tell us that x is equal to 5/4 plus or minus 511 over 4 I. And that's it. The numbers aren't as nice, but the process, nothing changed. We just had to work with fractions. And that's it. Now, there's another way we could write this, because both of the denominators are the same, yes? So we can have the 4. So we can say 5 plus or minus I square root of 511. We can write it as a single term, single fraction. And it's the exact same thing. Questions on this here? So this here is where it gets a little tricky, especially when the numbers don't divide evenly. But that is it for today. We have one more section of this here, which is tomorrow, 3.6. There is a part 7, but I'm not going to worry about part 7. We might come back to it later. It's solving systems of equations with quadratics and linear equations. So our test is going to be 2 weeks from Friday. Because 2 weeks from this Friday. Because next Friday, y'all are on fall break. It will be the Friday after. Because the 4 days we get back from the break, that Tuesday is going to be the makeup day. That Wednesday is the review. That Thursday we'll go over the review, and Friday would be the test. So the midterm in here